We have learned 3 different ways to solve quadratic equations so far. So remind me what those 3 ways are. Factoring was one method. Completing the square was another method. And square roots was the other method. So those are our 3 ways to solve quadratics. We're going to be kind of reviewing some of those ideas today. Except last week we learned about this new kind of number called an imaginary number. And our solutions today are going to be imaginary. Factoring will not work if what we're looking for is an imaginary solution. So factoring is going to be out as an option. So that leaves us completing the square or taking square roots. Could we solve this equation by taking square roots? Why or why not? So yes or no, and why or why not? It's no, but it's not because it's negative. It's because there's the single x term. So to be able to solve with square roots, you need an equation that has just a squared thing. Because if we were going to solve this with square roots, what we would want to do is get that 3x squared alone and then take a square root. But then on the other side, we're going to have that 6x, and we're going to take a square root of it. So now I have a square root of x. I'm not getting any closer to finding out what x is. So we cannot solve this one by taking square roots. That means we need to complete the square. When we complete the square, we cannot have a coefficient in front of the x squared term. That is not possible to do. So we need to get rid of that 3. What do we do to get rid of it? Divide everything by 3. So get x squared minus 2x plus 4 equals 0. What do I do next to complete the square? Subtract 4 from both sides, so we get our variables on one side and our constant on the other. Why did I leave a gap?
Because you need to write the square of the half too.
Yeah, I have to write our special number, which we find by taking half of that middle value and squaring it. So what's our special number going to be in this one?
Negative.
Positive 1, because when we square something, it becomes positive, right? So we're going to do negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. So I add 1 in there. I also must add it to the other side, because remember, an equation is a scale, and everything you do to one side, you have to do to both sides. So we have to keep it balanced by adding 1 to both sides. What do we do next? Factor. How does this factor? X minus 1 all squared. Each term plays a role in the factoring. We take the square root of the first thing, so the square root of x squared is x. The sign of the middle thing, so we take that negative from the middle term, and then the square root of the last thing, the square root of 1 is 1. So each term plays a role in the factoring. Square root, sign, square root equals negative 3. Then what? Take the square root. So x minus 1 equals, what do I need when I take a square root? What happens? You get a plus or minus square root of, how can I simplify the square root of negative 3?
Or it's I, the 3i.
Yeah, so we can break this down into being the square root of 3 times the square root of negative 1, like we learned to simplify square roots. The square root of 3 is not pretty, so that's just going to stay. And what we learn the square root of negative 1 is? I. That I is not under the square root, it follows the square root. It's a negative if it's under the root. Once we take it out of the root, it becomes an I. We're not totally finished, though, because we want to know what x equals, so how do I get x alone?
Plus 1.
Add 1 to both sides. So you get 1 plus or minus square root of 3i. You may write this plus or minus the square root of 3i plus 1 if you want, and do them in the other order. I will always write it this way because this is that a plus bi form where the I should be the very last thing we write. It's not wrong to do it the other way. It's just not the standard procedure of doing things. But I wouldn't mark it wrong if you did them backwards, as long as you don't actually add them together and make it like the square root of 4. We can't do that. Okay? Questions? So we're using the same process of completing the square that we've done before, except we just ended up with an I in our answer. For this next example, again, I cannot solve with square roots because we have that plain x term, an x to the first powered term. So we need to complete the square. What do I do first? Subtract 76 from both sides to get the variables on one side with the constant on the other. Then we need to fill that gap with our special number. What is it going to be in this problem? 64. Take half of the middle term and square it. Half of 16 is 8. 8 squared is 64. Add 64 to both sides. Factor. How does this factor? X minus 8, all squared. Square root, sine, square root. Okay, so each term plays a role. Equals what? Negative 12. Then what? Square root both sides, and I get x minus 8 equals. Now we need to simplify the square root of negative 12. How does 12 break down? So we could go 4 times 3 is 12, and then that negative. This will break down as 2 times the square root of 3.
What's this?
I don't understand.
This process?
Yeah.
Completing the square.
Okay.
Yes.
I don't understand how you got 2 the square root of 3 from 4.
The square root of 4 is 2, so I took the square root of that because 2 times 2 is 4. Square root of 3 is not pretty, so we just let it be. And the square root of negative 1 is defined as being I. What else do I need that I don't have in my answer there? Plus or minus anytime we take a square root, right? And then the final step, I need to know what x equals, not what x minus 8 equals. So what do I have to do? Add 8 to both sides. Don't add 8 to the 2. It's its own thing. So 8 plus or minus 2 root 3i.
Why can't you add it to 2?
Because the 2 is part of this coefficient of I.
Okay. Well, if it didn't have I, then you could add 8 to it?
If it didn't have I and it was a nice number, like if it was just, so as a side note, like a completely separate type of answer, if we had something like anytime there's an I or a square root, just keep. Other questions on this example before we move on to a third example? What method should I use to solve this problem? Square roots. Square roots are going to work well on this problem because there's no singular x term. There's just an x squared term. So what would I do first to solve this problem?
Divide by 2.
I have a few options. I could subtract something. I could subtract 2x squared. I could subtract 48. Or I could divide by 2. This is a legal thing to do first. I'm going to subtract 2x squared from both sides. And then I'll divide by the negative 2. If you divide first and then those two steps are interchangeable. Either way, we should get ourselves to x squared equals negative 24. What do I do next? Take a square root. So I get x equals, we need to break down this 24. How are we going to break it down?
2 root 6.
So it's 4 times 6, and then we've got that negative 1. So that gives us 2 root 6 I. And what else do I need? Plus or minus. And that's our final answer because x is all alone.
Wait, why do you need to add I to the end then?
Because that's what the square root of negative 1 is. The square root of negative 1 is I. So whenever we have a negative under our square root, our final answer should be an imaginary number.
And they're plus or negative too.
The plus or minus happens anytime we take a square root, whether it's real or imaginary.
You have to factor the last one. Remember when you did like the parentheses thing?
That was completing the square in the last two examples when we had those parentheses. And so that's when it was a different method.
Okay. How come you didn't simplify the 6 more?
6 could break down to be 2 times 3,
Yeah.
but neither one of those are perfect squares, so it doesn't clean up at all. We're only interested in breaking it up into perfect squares. Good questions. Any more questions before we go on to a fourth example? All right, what method should I use to solve this one? Square roots again. Again, there's no singular x term, so square roots work well here. I'm going to start by subtracting 1. What do I do next? Divide by 4. Do not use decimals for your answers. Leave them as fractions. Decimals will be considered incorrect. What do I do next? Take a square root. What do I do when I take a square root of a fraction?
Multiply or no?
Square root each of them? Then, how does this simplify? What's the square root of 1? What's the square root of 4? So this one worked out really nicely because both of those numbers were perfect squares. What if it didn't work out nicely? Like, what if it was square root of 1 over square root of 3? What would we need to do? Multiply both top and bottom by that square root on the bottom. That was called rationalizing the denominator, where we're not allowed to leave a square root on the bottom of our final answer. So if it didn't break down nicely like the square root of 4 did, then you would multiply top and bottom by that square root to simplify your answer. All final answers must be completely simplified. All right, we've got one more example. What should I do here? Yeah, the easiest way to solve this one would just be to take a square root of it as is. You cannot square it out and say that it is squared plus 16. Super common mistake, but you can't distribute a square that way. It is not x squared plus 16. You could multiply out x plus 4 times x plus 4 and then FOIL that, combine like terms, clean stuff up, and then go through the process of completing the square. But that is definitely not the fastest way to do this one. The fastest way to do this one is just to take a square root. So that gives me x plus 4 equals what?
Negative 5.
Plus or minus? 5? I. Plus or minus always. The square root of 25 is 5. The negative gives us an I. I need to know what x equals, so what do I need to do to finish?
Plus 4.
So I get x equals negative 4 plus or minus 5i. Questions?